Now it is a new chapter, wave optics. All the laws of reflections and the reflections of light explained well on the basis of the corpuscular theory. That is, whenever the light enters in a denser medium, it bends towards the normal. When it goes from one medium to another medium, there is a change in the velocity. All these facts are in the corpuscular theory. But this theory failed to explain the some phenomena like the interference, diffraction, etc. This phenomena of interference, diffraction, polarization can be explained well on the basis of wave nature of light. Wave theory was proposed by Sir Huygens for the first time, but it was not accepted primarily because wave required medium for its propagation, but light required no medium for the propagation. This difficulty was solved when Maxwell put forward his famous electromagnetic theory of light. So, the wave theory is accepted and the phenomena like interference, etc. will be explained on the basis of the wave theory. Now, in this chapter, we will study the following topics, that is a wavefront, Hydrants Principle, behavior of the wavefront in mirrored lens and reflection of light, refraction of light. We prove these laws on the basis of the Hydrants Principle. The coherent sources, interference, Young's double slit experiment, diffraction, width of the central maxima, difference between the interference and the diffraction. Now we start with wavefront. To understand the concept of the wavefront, let us consider a water in a tank. As we dip a finger in it, waves begins to spread in outward direction in the form of concentric circles. A crest advances and is followed by a trough and a crest and so on. Crest and troughs both are circular. Locus of all the points in the same phase is called wavefront. Thus, in the case of the disturbed water surface, circular wavefronts advances forward away from a common center in the form of the concentric circles. So what is a wavefront? The wavefront is the continuous locus of all the points vibrating in the same phase, and the line which is perpendicular to the wavefront is called ray. Here, this red color is a wavefront. This one is also a wavefront. It is a wavefront. This one is a wavefront. So, continuous locus of all the points which are vibrating in the same phase is called a wavefront. And the line which are perpendicular to these wavefronts is called ray. These are rays. And the points, these points, blue color point, this black color point, these are called wavelets. So what is a wavelet? It is the point of disturbance due to the propagation of light. Now the shape of the wavefronts. The geometrical shape of the wavefronts depends on the source of disturbances. Some of the shapes are spherical wavefronts. Spherical wavefronts are produced by the point source because all the points which are equidistant from the point source will lie on a sphere. All these points which are equidistant will lie on the same sphere. So the wavefront of a spherical point source is a spherical wavefront. The cylindrical wavefront, when the source of light is a linear in shape, then the wavefront is a cylindrical wavefront because the locus of all such points which are equidistant from the linear source will be cylinder. Then the plane wavefront. When the source of light is situated far, far away from us, then we are receiving only the part of the wavefront, as in the case of the sun. It is situating far, far away from us, we are getting only the part of the wavefront, so it appears as a plane wavefront. This blue color is a plane wavefront, and this red colors which are perpendicular to wavefront is the ray of light. This blue color is a wavefront and the red color is the ray of light. Blue color is a wavefront and the red color is the ray of light. Now the Hydrants Principle. Each point on a wavefront acts as a fresh source of the disturbance of light called wavelength. These wavelets travel in all the directions with the speed of light. Position of the new wavefront is obtained by drawing the surface touching the secondary wavelets tangentially in forward direction. Now, to explain this principle, let us consider the construction of these wavefronts. Now, S is a point source of light which sends out disturbances with a spherical symmetry. Each point is a source of secondary wavelets. These red lines are the ray of light which are perpendicular to the wavefront, and the source is a point source, so its wavefront is spherical, and all these red dots are the wavelets which produces the disturbances, and this disturbances in time delta t covers the distance c times delta t, where c is a velocity of the light. When we draw a surface touching these wavelets tangentially in the forward direction, it gives the position of the new wavefront. Now, let us take one more example of the plane wavefront. It is a plane wavefront. All these points, red points, are the wavelets which covers the distance in a time delta t is equal to c delta t. And to find the position of the new wavefront, we draw a surface touching these wavelets in a forward direction tangentially. This will be the position of the new wavefront. In next topic, we will do the behavior of the prism, lens, mirror, etc. Thank you and have